Hello, this is Dan Alford with ARC Specialties. This is another in our series on designing for automation. People are worried about robots taking their jobs. I can assure you, if robotics was easy, my life would be easy, and it's not. Over all these years that we've been doing this, we frequently will see opportunities to change a design or change a process to make automation either possible, faster, better, or cheaper. And we'll share this with customers. Sometimes they take our suggestions, sometimes they don't. In this case, they didn't. And that's a valuable lesson too. This example comes from John Martin. John is one of our vice presidents and a project manager here, and he was tackling this job. What we're trying to do is weld this shaft onto a bearing. And you can see this V groove here. What we're trying to do is make this weld all the way around, 360 degrees around this shaft. And here's the problem. If we were to blow up this weld joint, this is what it looks like. We're trying to make this weld here at the top in a single pass. And that's easy to do, but the problem right down here is this void that I've hatched in. This void is underneath the weld, and since we're welding 360 degrees all the way around the part, and the gas inside the part is heating up, we're experiencing blowouts at the end of the weld because the tensile strength of molten metal is 0. So if there's any gas pressure at all underneath this weld, it would blow out. It's very problematic. What's the solution? This is what we recommended, is you simply eliminate that void, make that one solid piece underneath there, eliminate the volume of air and gas underneath this weld so there's nothing to expand and nothing to blow out the weld. Our ideas were rejected. So they had to come up with another way, and I'm not happy with the solution, but what we did was we reduced heat input and increased cycle time, neither of which appealed to me. But by doing this, we were able to create a smaller weld puddle, which is more tolerant of internal gas pressure, and we didn't get the blowouts that we're getting before. But the best solution would have been to change the design. But frequently we get pushback when we suggest the design ought to change because A, you have to change prints, you got to go through design review and all of that. But this would have been a perfect example that had we followed our recommendations, we could have welded this thing faster and more reliably. I hope this is a benefit to you today. I look forward to seeing you on future episodes.